Hello. So, hopefully this is on live. Hello, this is Junichiro, and this is the live tutorial for Houdini, a weekly tutorial for Houdini, which is called as Houdini Algorithmic Live. And this is the 81st episode for this tutorial series. And the topic for today is to create a kind of a random generated metro network using Houdini procedurally, and use that network to run some particles on top of these network as a train. So this is one of the example that I have, um, which has been created from this Ratatouille test geometry, and then procedurally creating a network like these using a very basic concept of Manhattan geometry, Manhattan distance, or Taxicab geometry. Then controlling the point positions on top of these network using a solver to run the points, and as a result, and these boxes are some random boxes generated from a original geometry to make it as a building. Okay, so this is the final things that I would like to create today. Creating a network and also running those particles on top of the network, as well as having some building geometry nearby the network. Okay, so that's my plan. And before getting started, let me first explain the overall process that I'm going to try to do today. Okay, with the sketch. So first of all, I'm going to give some input geometry which can be used as a guide to create a network, like a boundary geometry. Then in the second step, I'm going to plot some points inside the geometry, and then based on some distance threshold, I'm going to connect these points with other points, maybe by a distance, closest distance, or maybe a number of connections that each point can allow, and so on, and create some network. These, when you have created these kind of line networks, at the moment the line network is a bit too randomly distributed, so it doesn't really look like a metro network, like a clean metro network. So in order to make it clean, I'm going to use a Manhattan distance algorithm or Taxicab algorithm to create more of a diagonal using a straight or 45 degrees lines to connect each points, or reconnect the points using 45 degrees or 90 degrees angle, and so on, which will eventually clean up the network, more look organized. These, and finally I am going to run some train on top of these network. Maybe plot some points on each line and let it go on top of this network, and using those branches to change the line by themselves, maybe randomly. And maybe at the final step, maybe I can just create some outer buildings close to the network to make it more look like a three-dimensional, like structures or infrastructures or urban space. Okay, but all these are more of a random generated stuff, so maybe it could be a bit too randomish, maybe not too realistic, but the same idea could be used for many other purposes. So I think the process is still interesting. So that's what I'm gonna show, and let's see how I can do this from scratch. Okay, so first, I am going to create a geometry node and create a input geometry as a guide, first of all. So let's give any test geometry that you want to use. Since I have tested with using a rabbit toy, maybe I can just use another type of geometry, maybe backhead. Should be fine. Alright, so first of all, I'm going to plot some random number of points inside this geometry. So I'm gonna make this as a volume first using an ISO offset with some density, and then I am going to scatter some points inside this geometry, and the number of this point will be the number of node for the network. It can be considered as the number of the station for the metro. Okay, so let's create some null node as well to have the parameter in order to control the number of points. So let's see, I'm going to color this blue, then try to create some parameters, maybe in an integer, to define a number of points or a number of node. So let's say number of stops or something. And I'm gonna make it between 1 to maybe 200 in range. Okay, then copy this parameter and then paste it into this force total count for the scatter node. Okay, now you could choose either relax or only relax. Maybe it might be a good idea to relax because the distance between the points will be about the same, around the same distance, so might be useful in terms of creating a distant network and the network lines based on the distance. But it doesn't really matter. I mean, you could also check this off as well if you want to have more randomish pattern. Okay, so I guess I am going to make this turned on for now. And what I am going to do here is to first of all create some line network in between those points using some distance as a threshold value. Okay, so let's do this. I'm going to but first of all, what I would like to do is to, since right now the point is really at the random point positions inside a volume, so maybe it still is a good idea to align these point position maybe based on the grid, maybe snapped onto a three-dimensional grid. So let's try to do that first. In order to do that, I am going to use a points from volume, this one, and then try to create the volume, create the points out of this volume that I've created. Okay, so these volume can be used as the guide for these point to snap on. Okay, so what I'm gonna do is to find the closest point from this grid points and then snap onto that point, the closest point. Now it's a bit hard to see the points, so I'm gonna raise up the point radius a little bit. All right, that's good. Okay, so let's snap this first, which is pretty easy. I'm going to use the wrangle to do that. First of all, I'm going to find out the nearest point positions from the second input. And then get the nearest point positions out of this point number. Alright, now I can now move the current point position, these point position to the nearest point position retrieved from the grid points. As a result, all those points are snapped on top of the grid, just like this. All right, so as a result, you'll be able to get more clean line network in the end. Okay, now since I have just snapped the point position, some of the point might be in the same position, so meaning there are some duplicated points in the same positions. So maybe I can use the fuse to remove those duplicated points. Let's see, so before was 71, now it's 71, so maybe no duplication, but that's good. All right, now next I'm going to try to create a line based on some threshold. So to do that, I'm going to use a point wrangle. For each, going to work on each point, and probably what I'm going to do is to try to create a search radius from each of the point, and if there are some points within this radius, pick maybe a random number of points out of these found out points and then just draw a line like that. So let's do this. I am going to name this create line network like this. Okay, and first of all, I'm going to set some threshold value, which is going to be the search radius. So search radius. All right. Okay, let's see. And then I'm going to search for the nearest points within this radius using a near points function. So in order to do that, I'm searching for the input 0, so which is the first input. And then using the current point positions to search and use the search radius. Now there could, by using this near point for your self input, meaning the geo self input, the point yourself is being included in this searches, so always the first point retrieved from this new point is yourself, which is equal to at p. So we gotta ignore that point position. So if npt at the count of this searched result is more than 1, meaning if it's equal or more than 2, then that's when you want to start creating the line. Okay, so if it's more than 1, then I'm going to create a number of lines out of these points. Now maybe I can also define how many number of lines you want to create. So I'm going to create a number of lines as a parameter, another parameter. And let's say I would like to create 3 lines, maybe maximum 3 lines out of each point. All right, then what I'm gonna do is to use the for loop, maybe from 1 to a number of lines incremented I by 1. Okay, num lines. All right, and this I will be used as a index value right here. Although there are chances that there are like so many points found out within this search radius, so maybe it might be a good idea to just randomly pick the points out of these arrays for each loop. So let's do this. Can you hear? Maybe the audio is not so loud today. Okay, let me try to raise up the volume if it's gonna sound better. How's this? Maybe that's too loud. Let me know how it sounds. Okay, I just raised up the volume a little bit. All right, that's good. Now, where was I? So, I was trying to create the number of lines, and in order to pick the points out of these, let's create a random index for this array. So I'm going to create a variable called index, which is going to be an integer to access these points. And then first of all, create a random value using some seed, maybe based on the point position. And that's probably it that I need. Also based on the for loop I value. So let me try to multiply this by some random constant value. And maybe I can add some seed value so that I can change also the random values by yourself. Okay, so the result of this random value will be in between 0 to 1 float value. So I want to convert it into an integer value to be used for the index. So first of all, I'm going to multiply this 0 to 1 value by the length of the array, right? And then make this a integer value by making a floor value. Okay, and then now I think I can just use this as an index value, so npts. Now one thing that I need to be considered is that right now this floor value might be possible to create a value 0, but we don't want to use 0 as an index for this array because as I said, the 0 means is that you get the point yourself, which is at ptnum or at p. So we gotta make sure that we're not choosing the 0 for this value. So to do that, I'm going to clamp this so that the minimum value will be always equal to 1. So max 1. So get the max value either 1 or this one. As a result, you are not going to get any 0 value out of this. All right, so wait a minute. Now this doesn't have to be called as an index, but maybe I can just call this npt, the picked point number. Oops. this itself was actually an index value. All right. Now the point has been picked. Let's try to create the line in between those, the current point position and the result that's been found out with this search radius. So let me just change the seed value and try to create a line using at prim 0 poly line between the current point number and the NPT. Okay, maybe the radius might not enough to search. Let's raise up the radius to see if I can create those line network. Okay, looks good. Starting to create some line network, which doesn't really look like an original geometry, but that's fine because it's a bit low res. We don't have much number points right now, but we could try this out later. All right. Thank you for your comments. And if I change the seed, I can change the pattern, how the line should be created. Okay, so far that's good, but as you can see, this is a bit too randomish right now, which is not really clean in terms of the network. So we're gonna clean this up to make it more organized network. All right. To do this, first of all, I would like to remove the duplicated line. There are chances that the duplicated lines has been made. Maybe the line has been created from this point to this, but from this point, maybe another line has been created from this point to this point. So there is a chance that the duplicated lines has been created. So in order to remove those duplicated ones, I can just use a convert line node. Okay, so previously it was 142 lines. Now it's 123 lines, so maybe some of the duplicated line has been removed. All right. Now what I would like to do now is to make this as a more diagonal or more straight based lines based on the X, Y, and Z axis. Okay, in order to do that, I'm going to use the idea of this taxicab geometry. So consider this is like the street of Manhattan, and consider the cab would like to go from this point to this point. Now, initially, I mean, this just want to go straight ahead if it's possible, but since the cab has to go through the road, you have to find out the closest distance out of these grid. So the option is to choose either this red, blue, or yellow. So what I'm gonna do is to try to use this idea, and even though we have this straight line, we're going to split it into X, Y, and in this case we have 3 dimensions, so Z axis. And probably using this red lines is a most easiest way to like split the straight line into these straight line, these directional line into these straight lines. In this case, if we have like green lines in 2 dimensions, you just need to split this green line into 2 in order to create this Manhattan distance or Manhattan taxicab geometry. So one line goes straight on Y direction and one line goes X on X direction. Okay, so if we have one more axis, in this case Z axis, then we just need to add one more line. So in total we can just use 3 red lines in order to create a straight taxicab geometry for any kind of directional lines. Okay, so let's try to convert any kind of line into 3 lines using X, Y, and Z, which should be straightforward. Let's think about this, how we can do this in Sketch. So let's say we have a line like this, and this is 90 degrees, and this is 90 degrees. Okay. Oops, where'd it go? Okay, so what I would like to do, wait a minute, no, this is not the original geometry. Sorry, but the original geometry that we have is this green line, which is presented as a 3-dimensional line, and if we wait a minute, what's happening? Let me just change this to brush tool. Why is it changing to a sorry, so let's say if we have an X, Y, and Z direction, maybe this one's X, this one's Z, this one Y, and if we project this curve line into each axis for the Y, looks like this line, for the Z looks like this line, and for X looks like this line. And if we add all those lines together, then we'll be able to create a same lines, just like the addition of the vector. Now the things that I draw here doesn't really look like what I would like to do here, but the concept is you need to have 3 lines add up to create the original line. Okay, so most of the time when we do this, we're just using the vectors without visualizing its direction, but in this case we can directly visualize this vector, each axis value, one by one as a line itself, as a line geometry itself, and then as a result you'll be able to convert this straight line into a 3 axis related lines. So which is easy to do actually. Let's try to do this. So I'm going to name, wait a minute, I think I have some problem with my keyboard. Okay, maybe some key has been pushed or something. What's happening here? Okay, sorry for that. So I'm going to use a primitive wrangle. Wait a minute. Okay, I think I'm having some problem with some mouse or keyboard and something. Maybe due to my Sketch. Okay, I think that's... Oops, what? Okay. Let me try to... I think some option key has been pushed continuously for some reasons, not sure why. Let me just reset my keyboard. Oh my. Okay, I'm not not sure what's happening here. Okay, I think it's being fixed. Hopefully. Alright. Okay, sorry. So where was I? Wait. Okay, something just happened. Okay, I think the connection between the iPad has been disconnected, so it's not a problem. So I'm gonna create a taxicab geometry, or taxicab lines, should I say, and with the primitive wrangle. So currently I have these lines, and I'm gonna access to each line and convert it into a taxicab geometry as a polyline. Okay. So in order to do that, first of all, I'm going to get the first point position and the second point position of the line using a prim points. Then get the point position for the first point and the second point from this point numbers. Since each primitive is considered as a line, so I think there's only 2 points for each primitive, so I can just do it like this in order to get the first point and the second point position, right? And first of all, I'm going to calculate or get the vectors from the first point to the second point by just subtracting those point positions. So direction is position 2 minus position 1. So this is the vector value goes from one point to another, right? Now what I'm going to do is to convert this or split this into 3 vectors. One for x, one for y, and one for z. Okay, so first of all, direction x is just retrieving the x component out of this direction. And for the other value, I'm gonna make this 0. For direction y, I'm going to get just the y value, y component, and then for the z value, direction z, I'm just going to get dz component like this. Now that I have 3 vectors, I can try to create a point position using those 3 vectors. So the first point is the same, so we can just use the same point position. Now the second point position will be this point position plus this direction x, or maybe direction y or direction z. Maybe you can just choose randomly. But let's try to do let's try to test from going from x, y, and z. So new position 1 can be position 1 plus direction x, okay? And new position 2 could be position 1 plus direction x plus direction y. Now the final position can be either adding position 1 plus all x, y, z, or it's also same as the position 2. So I can just use the position 2 for the final point position. So now that I have 2 point position being calculated, I can add a new point position using add point. Like this, and then connect all those points as a polyline to see if I can create those taxicab geometry. So let's try to do that. Polyline is equal to add primitive polyline. And since I think I have in total 4 points in this case, maybe I can use the array for the final input for this one. So like, let's say new PTS. I'm gonna create this new PTS array to contain all the points that I want to use to recreate the polyline out of this line. Okay, so the first point could be a current point number or the point for this position 1. So that is PTS 0. Now the second point will be this NPT1. So NPT1. And the third point is this NPT2. And finally, the final point position was same as this one right here, which is PTS 1. Right? Okay, so some polyline has been created. Now we also need to delete the original lines, which is not necessary anymore. So I'm going to remove those using a remove prim to see only the created lines. Now you can see that the line has been converted into a taxicab geometry, which more looks organized than the one before. And if I try to select one of those geometry, I can see that there's always 3 lines. 1, 2, 3. Okay. 1, 2, 3, and so on. Sometimes if the line is at the same like axis, maybe there's only 1 lines or 2 lines, but that's not really a big problem. What we need to know is how we converted this random directional lines into 3 different components and create this straight based lines. Okay. So far looks good, I think. Now there is a chance that we want to change the order of this X, Y, and Z. Currently I'm adding from X to Y to Z, but if we change the order for this one, like for example if the Z comes first and then maybe a Y comes next, then the whole network will change like this. So maybe it's a good idea, maybe it might be a good idea to be able to change the order of this addition, maybe based on the randomness or maybe random seed. Okay, to be able to create more variations. So to do that, we think it's a good idea to make these XYZ component or XYZ direction more general. Before doing that, I gotta fix this. Yeah. Okay, so in order to make this general, I'm going to insert these 3 vectors into a 1 vector array. So I'm gonna create the directional array, a vector array like this, and then going to create an array containing all direction X, direction Y, and direction Z. Now what I would like to do now is to shuffle these array based on some random seed. Based on some random seed, maybe the direction Y comes first, or direction Z comes first, and so on. So in order to shuffle the array, I don't think there are such functions in Houdini, so I'm gonna create that using a rather simple method. And let's also look at some vex functions, what kind of functions that I could use in order to shuffle the array. Now I think I can use the order or reorder function. So reorder is used to order the values based on the indices. Okay, so if I could create a random indexes or random indices as an integer, which contains the same number of elements as this array, in this case 3 elements, then we could use that to shuffle the geometry. And for each indices, I can just pick the random values for each element. So I'm going to create a for loop. Well, first of all, I'm going to create a indices array. Like this, and then create a for loop. Loop through all the directions. In this case, we have 3 directions, so I'm going to create a 3 iterations, 3 loops. And then for each indices, I'm going to append some random index numbers, maybe using the random functions based on a primitive number plus a I value. And maybe additional seed value, which you can input by yourself. Now, this random itself will create a float value in between 0 to 1, but what we need to have is the integer value inside this indices. So let's try to multiply this by, I don't know, some big numbers like 10,000. Then make a float value out of this float number to make it as an integer. Then apply that inside, append it inside this indices. Now, as a result, you'll be able to create a array which contains the 3 random integer values contained inside this. Then we can reorder this directional array using a reorder function based on this indices. Right, now what I want to do next is to replace these direction x and direction x plus direction z with the value from directional array. So the first one will be directions, the first value of the directions. It could be x, it could be y, something. And the next one could be 0 plus 1. Oops, maybe something wrong. Okay, and doesn't really look like what I would like to have. So probably something is wrong. Let's see why. And sure why. Let me first check the indices, how the indices look like. And see what happens. Okay, so the indices looks okay to me. Yeah. In order to use it for the reordering, I think that's fine. Let me go back to the vex functions page to see the reorder. So returns the reorder version of the characters or the array, so it should be fine. Right now. And let me also check the directional vector value. First of all, I'm going to check this direction x or direction 0 Also, I'm going to check the direction 1 and see how it looks like. It should be either, wait a minute, everything is 0. Okay, something's wrong. Okay, what seems to be wrong here? So I have, if I didn't reorder it, okay, now it works. So seems like something bad happened when I reordered it. Okay. All right. Let's see what's wrong. Maybe I cannot really use the indices that I have created by myself. Maybe I can try to create the indices using the other vex functions, which is called as argsort. So let's try to use this one to create the indices. So in order to use this, I am going to first of all, I'm going to create a arg as a float value. And in this case, I don't really need to use the convert it into an integer, so I'm just going to use the random value as it is from 0 to 1, like this. And then append this value inside the argument array, like this. Now I'm going to recreate the indices array using arg sort, using the argument arrays. Now I'm going to reorder the directions using okay, now seems to work. Seems like I cannot just make the indices by myself, but need to be created using this one. Maybe there are some rules for this integer value. Okay, now I don't want to remove the original line, so just like this. Okay, now I am now be able to shuffle this order. So if I change the seed, I can change how the connection looks like by changing which component comes first, X, Y, or Z. Okay, looks already nice, I think. Now, let's go to the next one. Next things that I would like to do is to create a more of a diagonal curve or diagonal lines. Currently, there's only like 90 degrees like angle for these network, but maybe sometimes I would like to have some diagonal curve, maybe based on the 45 degrees for this direction, maybe for this direction, and so on, for this direction, and so on. So let's also try to add this 45 degrees diagonal directional curve to this 90 degree polyline. Okay, so I'm going to also consider what will be the rules for that. So now I don't have a pen right now, so I'm gonna try to draw it with my mouse. So let's say we have this polyline. What I would like to do is to draw some curve like this, in between those where the 90 angle is there. And as a result, I would like to create this kind of diagonal curve. combined with the original geometry or original polyline. Okay, to do that, one of the idea that I could think of is to, first of all, let's say I have this geometry. Now, starting from the point 0, we have point 1, point 2, and point 3. Okay, and we can consider the distance between the point 1 and point 0 and point 1 to point 2. Okay, D1 and D2. Now, since I would like to make it as a 45 degrees, the maximum distance or the maximum distance that I could use from this point, or I mean from this point, is this one, which is smaller than the D1, D2. So what we need to do is to first of all get the distance value, which is the minimum of D1 and D2, which in this case this distance, and then use this distance to estimate the point that I would like to start drawing the diagonal line and create the diagonal line like this. Okay, so this is the first step. Now for the second step, we have kind of a leftover space right here. And we have another full length line right here. So we are going to recalculate the distance D1 quote D2 quote and get another minimum distance out of these two distances, and probably this is smaller in this case, so I'm going to draw another diagonal line like this. And then for the rest of the curve, I'm gonna make it straight like that. So in result, what we are going to get as a curve is, wait, not this direction, like these directional curve. Now I could also multiply some ratio value to this distance, which is in between 0 to 1, so that the diagonal line can be start from some random positions to make more variations in terms of the curve bending, right? So that's what I would like to try to implement, and in order to do that, we also need to consider if the line looks like these or if the line looks like this. If the line looks just straight, then we don't really need to create any diagonal lines, so we gotta skip this. If we have one angle, 190-degree angle, then we just need to do one. We just need to add one diagonal lines. If we have 3 lines, then we can add 2 diagonal lines. Okay, so that's the rule. So it might be a good idea to organize the current polyline, whether it has just 2 points, 3 points, or 4 points. Currently every polyline has 4 points, even though if it's straight or not. So let's try to make it a bit more organized so that if it's straight, then we only have 2 points. If it's just 190-degree angle, then we have 3 points. If it bend 2 times, then we have 4 points, and so to do that, it might be a good idea to do it all inside this wrangle node. So let's see where we could do that. Okay, so this is where we are adding 2 points, right? Now there are some conditions that we don't really need to add those points, which is if the distance between this end position 1 and this position 1 is equal to 0, or the position between this position 1, or I mean this position between this end position 1 and position 2 is also equal to 0, then in those cases we don't really need to add a new point, but we can just skip it. So let's check the distance between the n plus 1 and position 1. If it's close to 0, then, or if it's more than 0, then we can add the point. So if it's at least more than 0.001, then we can determine that this has some distance separated. So in those cases, I can add a point. Now I can add another rule here. The distance between the in position 1 and position 2 is also more than 0.001. So in those two cases, in those conditions, maybe I can add a new point. Okay, and since if the condition doesn't really meet, then I do need to recreate this NPTS array. So let's bring this beforehand somewhere around here, starting with just point 1, or the first point position. Then only if the condition meets, then I'm going to append this npt1 to this array. Same for these. If I'm just going to copy these conditions here. If the in position 2, in position 1, in position 2, in position 2, the distance is more than 0, then I'm going to create a new point and add it to this NPTS array. Alright, now finally I can append the final point number, which is in PTS1. Now the visual doesn't really change, but the number of points has been changed, and some primitive has 2 points, sometimes some primitive has 3 points, and so on. Let's see if we could find out some lines which only has 3 or 2 points. For example, this one has only one directional angle. So if we try to pick this up, nope, that's wrong. This has actually 2 bending. Let's see where I could find those. Somewhere, maybe this one. Yeah, like this one. So if I look at the point count number, this is equal to 3. So previously it was equal to 4, but we only need 3 for this one single bending. Okay, something wrong with the network. I'm not sure if the network is okay. Hopefully it is. Right. Okay, so now the geometry has been cleaned up a little bit. It's time to make this, a diagonal curve out of these taxicab geometry. So let's have another primitive wrangle. Name this diagonal curve, or diagonalize maybe. All right. So another set of rules that I have to think of First thing first, I'm going to retrieve all the point numbers out of each polyline. So okay, now as I said, if we have only 3 points, I just need one diagonal line. If we have 4 points, we have 2 diagonal lines. If we only have 2 points, then we can just ignore it. So let's create that kind of conditions here. I'm going to create a for loop based on changing the total number of loop based on the point number. So the total point number minus 2 should do the job. So if the point number is equal to 2, then no loop, it's been processed. If it's equal to 3, if this is equal to 3, then 1 iterations is going to be done. If we have 4 points, then 2 loops, 2 iterations for the loop, and so on. Right? And I'm going to get a 3 point in order to get the first point number, second point number, and the third point number, right? In order to create this diagonal line, to calculate the distance, and so on. So PT0, let's say, is equal to PTSI. PT1 is equal to PTSI plus 1. PT2 is equal to PTSI plus 2. And I'm also going to get the point position out of these point numbers. So vector pos 0 and so on. Just gonna copy this. 1, 2, 1, 2. So let's first calculate the distance between the position 0 and position 1 and position 1 and position 2, which is correspond to these value. This distance is from position 0 to position 1, and this distance is in between position 1 to position 2. So float dist 1 is distance between position 0 position 1. Distance 2 is equal to distance position 1 and position 2. Alright, and then what I'm gonna do is to get the minimum distance out of these two distances, so, or the smaller distance. So I'm going to name this temporal minimum distance, and then use the minimum function between the distance 1 and distance 2. So as a result, you'll be able to get the smaller value, either distance 1 or either distance 2. Right. Now that I got the smaller distance, I can now what was I trying to do? I can now try to create this point position. Let's say this is D1, this is D2. And what I would like to do is to calculate or get the point position somewhere around here and create the diagonal lines right here, and also get this point position right here. So this, let's say this is called as end position 1, this is called as end position 2, and we would like to get this value here based on this distance. And if I just use the distance as it is, we can just create this line. But if we multiply this distance by some ratio, then we'll be able to control where does this line goes to. So let's try to control distance by multiplying it using some ratio value. It could be random, but it might be a good idea to control it by yourself for testing. So first of all, I'm going to create a ratio flow parameter by myself, starting from 1, and then multiply this distance by this ratio. Okay. Now let's try to create a new position. The first position can be determined by starting from the position 0 or position 1 maybe. If we think about like this, let's say if we have this and this is position 1, position 0, position 2, and we do know the direction between position 1 to position 0, position 1 to position 2 by just subtracting the point position between. So we can say starting from position 1, we can add some vectors to go to this way or either to this way with the value d multiplied by ratio. Okay. And then determine where the point should come. And this distance has to be same for this direction and this direction in order to make it 45 degrees. So, and we do have the distance already, so we just need to give some vector calculations. So first of all, I'm gonna get the normalized direction going from position 1 to position 0. So position 0 minus position 1 normalized and multiplied by the distance. And the second point position will be position 1 plus normalize position 2 minus position 1 multiplied by tm distance. Okay, so these are these should be the new position that we want to add. So let's try to create a new point as a geometry using np add point. And then okay, so this is how it looks like right now. And let's try to recreate the polyline based on those informations. Now, right now, but if we have if we want to add additional diagonal lines for the next loop, then we gotta consider something else. So, but this is to test if the single diagonal line is going to be okay or not. So I'm just going to limit the loop by 1 for now, so that it will be easy to debug. So currently I only have 1 diagonal lines for each polyline. Now let's try to recreate the polyline as a diagonal line. So first of all, I'm going to create an empty polyline, maybe outside the loop, probably, or maybe create a point number arrays to be used to create the polyline. So npts create the empty integer array like this, and starting from a very first point, which is pts 0, the very first point number right here. Okay, then I'm going to then append this npts with these npt1, npt2, and for the other point I can try to append the last point from the PTS. Now, obviously this is missing some points in between, especially if you have 3 lines, but let's see if it, I just want to check if the first diagonal lines has been created or not. So let's see. Now I'm going to create the final polyline using these NPTS, and then as a polyline, and then also remove the current straight based line, straight taxicab geometry. So remove prim num, like that. Okay, maybe that wasn't a very good idea because I'm missing a bunch of points actually. So probably I do still need these loop, and also let's say this is let me see. Well, actually, if I look at this, obviously something is wrong, especially like these. So previously it was like this curve, and okay, so first let me just pick this curve so that it'll be easy to debug. I'm just gonna pick a single curve to test, right? And see what happens. First of all, I'm gonna check what's the point order for this one. Okay, well, one problem here, the point number is a bit random. The first point goes this one, the second point goes here. So I don't think we can just use this prim points as an ordered number, but instead I think I should use the prim a vertices or something, which should preserve the point order based on the primitive shape. So let's go to the prim vertices and use this one instead, which you'll be able to get the vertex number, the linear vertex number, I think. Then we can convert this linear vertex indices into a point number later. Okay, so BTS is prim vertices, and then I am going to loop through all the vertex numbers. And I'm also going to create an empty point number array. And then for each vertex number, I'm going to retrieve the point number related to these vertex using the vertex point, like that. Now I can append this point inside this PT array. All right. Now that should reorder the point array. Now, but I still have some problem here. Let's see what's the problem. So let's assume that the point has been started from here. So the first diagonal line has been created. Fine, I think. Now the problem is on the next loop, the point has been started from this right here. So we actually want to start the point from this point where the diagonal line comes to this. Or we do need to consider the leftover distances. So actually, originally, if the shape looks like this, and if the diagonal lines comes like this, then the only way we could go is this way, straightforward, without any diagonal lines created. Okay, so and we are missing that conditions. So in the second loop, I think the first loop's going okay. We can check that by just trying to delete one of the point out of this. Maybe just delete this one and see what happens. So in this case, we have 3 points, one angled, one 90-degree angled. And so if there's only one angle, then one diagonal line's been created without any problem. So that's good. So what we need to do is this conditions. If we have two diagonal bending, well, I mean two 90-degree bending. So in this case, if I is equal to 1, right? So in these cases, let's see. First of all, if we have a diagonal curve like these, then we need to consider the minimum distance in between this length and this length. In this case, the minimum distance is equal to 0. So in those cases, we no longer have any diagonal lines for the second step. So what we need to do is to calculate the leftover distance that might be able to use for the additional diagonal line. So to do that, we do need to use some of the value calculated like here, especially this one right here. Okay, so this is the final distance. This is the final distance for the first diagonal line if the loop is the first iteration. Now after I have got this, I would like to use the same value in the next loop to calculate the leftover value. Okay, so let's try to create another variable called mdist starting from 0. Okay, and then do some another minimum functions between the distance 1 minus mdist and the current tmdist. So this doesn't give any changes in the first loop, but in the second loop the m distance should be updated. So in order to use this, I actually need to also update the minimum distance like this. Okay, so in the first loop, the m distance is equal to 0. So it is calculating the smallest one between the distance 1 and tm distance. Now in this case, tm distance is always the smallest or maybe equal to distance 1. So either way, this value will be chosen. And in the next loop, the minimum distance has been stored with this current, the first loop minimum distance. So in the next loop, you have a bit of smaller distance which has been used with the first diagonal line. So if the first minimum distance around here, then the leftover distance is this one in the next loop. In the next loop, first loop we are looking these pairs, this line and this line. In the next loop we are looking at this pair and this line and this line as a pair. So distance 1 means this distance. and subtracting with them distance, which is the distance that I have calculated previously. So what we have is the leftover distance as this. And we're gonna get the minimum distance between this one and this one, which is the current TM distance. And as a result, I should be able to get this curve right here at this distance right here, and be able to create another second diagonal line, which sounds really confusing, but let's see if it's going to work or not. Okay, I have some errors. I am having a spell mistake. Okay, so currently, something has been fixed, as I can see. No more X line has been created, but currently I only have 1, 2, 3 lines. That is because the ratio is equal to 1. The diagonal line is going straight to the second point. Now if I change this ratio, I start to see a second line is being created. So this is the first line, first diagonal line, second diagonal line, and straight line. So in total we have 1, 2, 3, 4 lines in this case. Well, seems like I also have a chance to have one straight line going y direction, diagonal line, straight line on x, or in this case z, then another diagonal line and one straight line on x. Okay, so this is like that. Okay, looks interesting. So this is how it goes. By changing this ratio, I can create different types of different variations of diagonal lines like these, and that should also work for any other geometry. So let's remove this blast. See if it's going to work on all the other polyline. So if it's 0, you have an original geometry. If it's 1, you have more diagonal oriented geometry. It's 0.5, you have a mixture of the straight and diagonal lines. Okay, looks good. And you can just use these ratio like a hand controllable values, or maybe you can also make it random as well. If you want to make it random, then what you just need to do is to change this to random related value, maybe based on the primitive number plus a loop iteration value plus some seed value that you can control by yourself. And if I change the seed, I can kind of randomly change how the diagonal shape look like. You could also use like the combination with the clamp to control how much diagonal you want or not, and so on. Maybe it might be a good idea to also multiply this randomness, multiply by the ratio, so that I can control the maximum diagonal value, even though if it's also random. So if the ratio is 0, even though you change the seed, it always is straight. But if I change the ratio to 1, then there is a chance that the maximum diagonal shape has show up. Okay, looks good. So now the shape is actually being, I I'm kind of satisfied with this geometry itself, the line network itself. As a metro network, I mean, it's not really, maybe in real life doesn't really look like this shape, but it's just a kind of a procedural, like fun, procedural like testing experiments, trying to show some way to create more clean Manhattan-like network shape. Okay, so this is one way you could do in three dimensions. Okay, so let's say I am good with these shape. I actually like the shape itself. Okay, now the network itself is okay. Maybe the final thing that I could do is to actually use this to run some train or some particles on top of the network as the animation. Maybe you could really create some like node network based on like shortest distance node and so on, going from one node to another node. Or maybe you, in my case, I'm just going to create some random path for each particle to run on top of the network, meaning just create a bunch of points on top of the line and then let those points run through the network randomly. Maybe if the point goes from this point to the branch, the point can go to the left, can go to the straight, randomly picked at a specific timing based on some random seed. If in real life, maybe you could create the real path between the station to go from one point to another. In those cases, maybe using the shortest find path might do a great job. But I'm not gonna do that. I'm gonna make a somewhat randomly walking or running train geometry on top of this network. Okay, so let's do this. Now, in order to do that, I would like to make the speed of the running particle constant, even though the length of these polyline is different. So in those cases, I cannot really use the UV because UV is based on UV in between 0 to 1. So instead of using UV, I'm going to use a kind of a distance metric value to sample from a primitive using UV sample function. So what I'm going to do is to apply some distance-based attributes to each point for each primitive, then use UV sample node to access to those distance-based attributes and use those to with a constant speed value to move the particle with specific speed. I don't know if it makes sense, but that's what I would like to do. And in order to do that, what I need to do is to first of all, let's say I have these line, maybe these line, and would like to make point travel from starting point to the end point with the constant speed. Okay. And in order to make it, and let's say I have another line, okay, and I also want to make those particles travel on top of this line with the same speed. Okay, to do that and to let point know where they are on top of each primitive, what I'm going to do in this process is to first of all, apply a distance-based attributes on each point on the primitive. Okay, so if the primitive has 4 points and starting from 0, then on the next point, what I would like to apply as an attribute is the distance from the first point. So in this case, maybe let's say D1. Now in the second point, what I would like to have is the length of this curve from the starting point. So the distance between 0 to 1 and distance between 1 to 2. That's the value that I would like to apply to the second point. And finally, what I would like to have right here, what I would like to have at the last point is the total length of the curve. So in this case, a perimeter. And applying these values as an attribute, you'll be able to sample the point position based on those distance value. Let's say if you want to have the point position on top of this curve based on the distance, maybe you have the quote, and the D quote distance is somewhere around here. The length from the first point to this point is the length of D quote. Then what I would like to do is by inputting this value, I would like to get this point position in order to determine where the point is right now at the primitive. And to do that, you do need to apply all those distance attributes to these points on a curve, and then use the UV sample function to access to the point position using these D value as a virtual UV value. Okay. And that's the trick. And let's see how I could do this in Houdini. Alright. So first thing first, I do need to apply those distance space attribute to each primitive. So let's do that. I cannot just use a parameter measure node, because it only calculates the total length of the primitive, but I do still need it, so I'm just going to calculate the parameter first. Then next thing I like to do is to calculate the distance for each point from the first point. So let's do this. I am going to use another primitive wrangle for that. And calculate the distance attribute for each point. So I'm going to retrieve each point number out of each primitive. Okay, and let's have a variable called distance, incremented distance starting from 0. And this incremented distance value will be incremented at each loop. And I'm going to loop through all the points, get the point number. Okay, and what I would like to do is to calculate the distance between the current point position and the previous point position. So this is the current point position. Let's say I'm going to call this PT1. The previous point position, I'm going to call it as PT0. And that is I minus 1. Now, there is a chance that this value will be negative especially when the I is equal to 0. Now that's problematic because we cannot access a negative index for the array. So in those cases, I would like to reset this into 0. So I'm gonna use a max function so that it always be 0. The maximum values always be, the minimum value will always be 0. Even though if it's negative, if anything is negative, it's going to be resetted to 0. So in the first iteration of this loop, you have two 0 position point, which is this one and this one. This point and this point number is the same at the first loop iteration. But that's not really a problem because what I want to do is to just calculate the distance between the current point position and the previous point position. And the first point position is the distance between the first point position and the first point position is equal to 0. So that's not really a problem because you want to start the distance attribute from 0. So vector position 0 is equal to 0.0 p at pt0, position 1 is equal to pt1, and you can calculate the distance between position 0 and position 1, right? And what I could do is to add this distance to the incremented distance and use this incremented distance as a attribute value for a current point number. So set point attrib 0. I'm gonna call it as t, and at pt1 I'm going to create a vector value for this t. Since if you want to use the UV sample function, you're gonna have a UV value as vector value. So even though if you only have one values to sample as a UV value, you still need X, Y, and Z value. Although I think I can have another value other than distance in this case, which is the primitive number. Yeah, I could access to the specific primitive number using primgroup, but if I use this option, then the calculation makes it really slow. So instead of using this primgroup, I'm gonna have the primitive number as one of the UV value. Okay, I think that's a neat trick to remember. Meaning, first of all, I'm going to create a vector value, and the first value is going to be used as the prim number. And the second value is actually the distance that I have just calculated right here. And the third value, I don't really have anything to sample for anything else, so just gonna say 0. So I have u as a prim number and v as a distance. Now when we use the UV sample, the UV sample I think is using some Euclidean distance based sampling, using this as sampling base. So I think it might be a good idea to change the unit between the prim number and the distance. What I mean by changing the unit is to make one of the number really high in terms of the values, so that it will be more how do I say, it will be less errors when we do the sampling between the geometries. So those cases, I'm gonna try to multiply this print number by 1000. Or you could do either way. I mean, maybe making the I distance maybe multiply by 1000, but I think this is more easier to deal with. since this is an integer value. So I'm gonna try with these. I mean, this is not really necessary to do. It's just some option to make less errors when we use the UV sampling. Not really sure if this is working great or not. I'm gonna test it out myself later. But a little trick here. Now let's see if this geometry has been, or the distance has been applied correctly to each point. So I have t value, t0, t1, t2, and t0 is the primitive number. t1 is the distance going from 0 to the total length of the primitive. Now the maximum t1 value is 0.78. Now if I look at the primitive, there's also a perimeter. And now this one says the maximum number is 0.87, so maybe something is wrong here. Because this value, this maximum value, and the t value, the maximum value of this t has to be the same, I think. So let's see what's wrong here. Okay, so let's see if I look at, so this is the primitive, the point, right? Now calculating the I distance, getting all the point numbers, making the loop. This is the first point, this is the current point, this is the point previously retrieved. Position 0, position 1, this getting the distance, adding the distance, and then applying the attribute to each point with this idist. Looks correct. Looks correct to me somehow. Right. Let me also try to apply another attribute. Just this I distance. Okay, and I'm gonna try to just get one single polyline to test out. So let me just select one of the curve, get a blasted. Okay, so let's check the perimeter. The perimeter is 0.5826. And if I look at this point, now this seems correct, right? So starting from 0, the distance incremented, and finally it goes to 0.85. Looks correct. And I right. Okay, another things that I might be forgetting is, as I said, the order of the point is not based on the geometry right now, so maybe I need to do the prim vertices instead of this PTS prim points. Okay, I think that's the reason. Yeah, I think so. So going back to where I was getting the prim vertices, I'm just going to copy these lines. Going back to this one, replace it with these, and see. Nope, still not. Doesn't really change anything. Maybe that wasn't the thing. Let me try to get this primitive 56. 56. Okay. And this is this has a parameter called a 0.87, and this one the t is, wait a minute, it does have 0.87. What's wrong? Previously I didn't really see this value, did I? And now it's gone. I am not sure why. I am guessing has to be something with these arrays, probably. Let me think a little bit why this happens. Let me know if anybody has some idea why this happens. So, okay. So if I have single geometries retrieved, then this seems to work just fine. Although the order is different, but that's not a big problem because it's all based on the vertex order, so should be fine. Starting from 0, and then the 1, this is the 2, so this one goes next, this one goes next, and so on, so should be fine. Alright. Okay, I see why. That is because some of the point has been fused, so that's the reason. Okay, so I think for each primitive the point should be unique. Okay, so that was the reason. Okay, so let me make those points unique for all those primitive. What's the easiest way to do that? Facet. No, this will make everything unique, I think. Let's see. Let's see if I can use this. Unique points. This will just make every point unique. It's not really what I want. Did I? Wait a minute. Maybe that's fine. Yeah, maybe this will just do the job. Yeah. Let's see. So, like this, I remove this and check the point number again. Alright, so the maximum is equal to the maximum of the parameter on the primitive tab. Okay, that's fine. This looks fine now. Now, where was I? I think it's also a good idea to resample these curves a little bit so that you have additional like sampling points to make a bit more high-res sampling. So I could use, maybe after calculating the measure, I can use the resample node with the resample by polygon edge option on, and make this length like 0.05 or smaller to have a bunch of points to sample. Maybe like these. Yeah, I think this is enough. A bit more. Alright. So make enough points for the UV sample to work in high res. Now, now it's time to actually use those values applied in each point with a UV sample to determine the point position. Now let's test this out. I am going to use the solver in order to animate the point, but beforehand I'm going to test out using a more procedural way, using a frame value. I'm going to use the point wrangle to... Okay, and I'm also going to create a initial points in order to move. So I can just use a scatter node to scatter on top of the current point. Maybe define how many points that I want to move. Maybe 20 points for now. And let's see what kind of attributes that I have on each point. So for each point, the t value has been sampled. That's good. This is useful. For the primitive, nothing. So, well, if I have this t value, that's fine, I think. And we're gonna use this t value to determine the next point position when we move the point on top of this primitive. So we have two informations from this t. One is the primitive number, which primitive is this point is running on top of, and the distance from the first point, which is t1. All right. So let's have that as the first input of this point wrangle and have this curve as a guide as a second input. And let's try to move this point with a constant speed by adding the t1 value. So just gonna create some random or some constant speed value with the parameter, let's say 0.01. In this case, I would like to move the point by the 0.01 distance for each frame. That's what it means by this speed. Now, in order to change the point position, first thing that I would like to do is to change the y value of t, the current t value that point has, by adding by speed multiplied by frame value. Okay. And based on this updated pt value, I would like to get the point position using this geometry as a guide. And this is where you can use the UV sample. Okay, where did the code go? So consider this t value. V at t is the UV value for the UV sample. So in order to get the new point position, you can use the updated t value as a UV to sample from the second input. UV sample, first input, the second input. What I want to get is the point position, and what I want to use as a UV is the t. And I'm going to use this current t value at inside a point attribute as actual UV. Now update the current point position with the sampled point position and see how the point will move. Okay, something happened. Let's try to see where the point is moving, if it's moving okay or not, by showing with the circle or a sphere. Okay, the sphere is a bit too big, a bit too small. Okay, let's see how it goes. Okay, so I can see that the point is moving on top of a single primitive with this t updated and with the constant speed. So testing, in terms of testing, this is great. So only thing that I need to do now is to move to those points on the solver, and once it reaches to the corner or the branch point, you want to change the direction from one primitive to the another primitive, meaning changing the t values, the x component of the t value from one primitive number to the another primitive number, maybe randomly. So in this case, once, let's look at this sphere right now, and once it reaches to the branch point, which is right here, this point wanna go either this way or go back to the original direction. Okay, and that's when you need to choose which primitive to go for the next frame, and then also choose whether the t value should be decreased or increased, going from 1 to 0 or 0 to 1. Okay, so that's the things you need to consider when you do the animations inside a solver. And once you are good with that, you should be able to create an animation running on top of this network. And the same idea can be used for any similar situations. So let's do this. I'm going to just delete those and create the solver. Test. Okay, so this is the initial points. This is the guide. And one additional information that I might need is to choose whether the point is going to the positive direction or to the negative direction, meaning if the t value is going to be increased with the constant speed or decreased with the constant speed, going forward or backward. So let's have another attribute to determine whether it's going forward or backward. Maybe as an initial value it could be random, so I'm going to just create some random value, either +1 or -1. So in this case I can just create random conditions. Rand based on the point position, maybe as well as some seed value. And this is in between 0 to 5, 0 to 1, so if it's less than 0.5, then you get -1, else you get +1. Okay, written as one line condition. It's also apply some ID retrieved from the point number. Maybe later on I would like to make it as a trail. So having an ID is a good idea to make a continuous trail line. Okay, so let's check. Let's look at the point attribute. And there you go. You have move direction integer attribute, which is either -1 or 1. So if it's -1, then you're going backward. If it's +1, you're going forward. Okay, that's what I would like to use it for. Alright, so I think that's the things that's the information that I need in order to go forward inside a solver. And this will be the last long code that I need to write here for today. So for each point, I'm going to access to the point wrangle and also refer to these network as a guide and connect it as a second geometry and run. Okay, now first of all, I do need to retrieve the current conditions of the point and see whether it's going forward or backward. Okay, so, and also determine the speed as well. Okay, so let's calculate the speed. Let's have the speed parameter. Speed. Let's make it as 0.01. All right. And also, we do need to know whether the point has been reached to the end or to the first point position, meaning if the distance becomes 0 or if the distance becomes the same as the parameter of the primitive. So let's get the parameter informations out of the primitive. Prim 1. Now we do need to retrieve the primitive number in order to use this. We currently don't have this primitive number, but we can estimate what is the primitive number for this current point by accessing to the t value. Now, if we access to the t value, the x component is actually the primitive number. Now we have multiplied by 1000 previously, so let's divide it by 1000 as well to make it as a real primitive number and make it as integer. Okay, now I'll be able to get the corresponding primitive parameter, and this will be the end value for the ty. Okay, now let's update the t value by, let's call this nt, and let's update the t value by adding the current t value by 0 speed and multiply by the moving direction, whether it's going to be -1 or +1. So if this is +1, then the point is going to be moving forward, and we're going to check if it reaches to the value parameter at some point. If this is negative, then we gotta check if the point goes close to 0 or negative. Okay, so if I at move direction is positive, then we would like to clamp the y value of the current t value, the updated t value, to the parameter. And then else if I move direction is negative, then nty becomes 0. Okay. Now I guess we do need other conditions right here. When the nty goes more than the parameter, and in this case and ty goes less than 0. All right. Now in those cases, we do want to switch the primitive number to something else. Okay. If we look at this primitive, let's see. Let's say if the point is been traveling this way and have reached it to the end right here, where the branch point, where the branch point is here. Now, when the point reaches to here, then the point has to choose whether you go back to the same primitive going this way, or using other primitive this way or this way. So based on this point position, you gotta pick up a specific primitive number, maybe a random primitive number, in this case out of 3. Right? So, and this is the condition where the point has reached to the branch point. So let's create a flag called next prim, and if it if it reaches to the end, then the next prim flag will be equal to 1, and only then you can switch the primitive to something else and choose whether you go negative or positive direction. Okay. Okay, now we do need to update the point position, even though we don't really switch or not, just like we did with the testing. So first of all, update the current t value with the new point, new t value, updated t value, and then get the point position using the UV sample, just like I did previously. Use what I want to get is the position value, and what I want to use as a UV is the t value, and using updated t value with the speed as the UV. Now I can get the point position. I can now update the current point position to this. Okay. Now now it's time to switch if this next primitive is equal to 1. So if next prim is equal to 1, then it's time to switch the primitive to go for the other branch. Okay, so first thing first, we gotta get all the we gotta get all the possible primitive numbers for each point that reaches to the end. So if the point comes here, then we gotta get the primitive number for this one, and this one. And to do that, what I could do as one of the option is to first of all search for the current point numbers at here at specific point positions, and then from those point numbers I can retrieve the primitive numbers from which belongs to those points. Okay, so that's how I think that's how I can change the value. Or I can directly get the t value out of each point. So what I just need to do is to randomly pick a point retrieve at this position. There's 3 options possible. So to do that, I am going to use a near points function with really small distance to check. Since I made sure that the point stops at this branch when it reaches to this point with these option right here. Okay. Now Now I should be able to get the number of points, at least one, which is including yourself. Okay. So if it's just one, then just choose yourself again and go back to the original direction, which I'm talking about this point. So when the point goes from here and reaches to the end, there's only one direction, one primitive, 1 points at this point. So you can just choose that one and then pick the primitive number out of those points, and then you just need to go the other direction in this case. So let's pick up a random point number out of this array. Just like I did for the other stuff, I'm going to use the random function based on the point number or point position. Either way is fine. Maybe point position multiplied by some constant value plus maybe based on the frame as well, since we are acting in an animation. And do we have a loop? Nope. So I guess that's all I need in terms of the seed. So maybe as additional custom seed value that you can change by yourself. All right. And then multiply this random value, which is in between 0 to 1, with the number of points. Then finally make it as a floor value to make it as an integer so that you can use it as an index for this NPTS to pick up the random numbers. Okay. Now that I have got this random point number, it's time to retrieve the t value, which belongs to this NPT, and t value contains two information. One is a primitive number, and one is either if it's a 0 or a parameter value, since that's at the end. So vector t, the next t is equal to point, second input t at npt. All right. Now, and what I would like to do at this point is to switch the current t value to the found next t, so that we can change the primitive number, and at the same time we can also change the distance attribute value. Okay, and finally we also need to determine whether it should go forward or backward, meaning we need to define whether the move direction is equal to 1 or -1. So in order to determine which ones goes which, we need to check the y component of this current this next t value. Let's say if this is the point that we're looking at. Now if the y component of this point is equal to 0, then we want to go this way. In this case we want to move positive way, meaning we want to constantly add the value to the y starting from 0. Now if this y component of this point has some value equal to parameter, this means is that this point is the end point, so we need to subtract the speed from those t value in order to go from this point to the other direction. So we need to check whether the y value is equal to 0 or not. So let's check this, check whether it's really close to 0. Then if it's close to 0, then we can move it to the positive direction. Else, move it to the negative direction. Like that. Okay. And I think that's pretty much it that I need to do. I think. Let's change the seed value and see what happens. So we have speed equal to 0.01. And let's see if it's going to work. Okay, somehow the point position has been moved a lot. Not sure why. Okay, something is terribly wrong. Right. Okay, what's wrong? It's this. It's moving really fast. Let's see. Let's see. Okay, so I had this perimeter. I have this moving distance. Speed comes from here. So this is the next. Okay, let's first comment these out so that it should stop at the branching point. Okay. Okay, not moving. Not really moving, is it? And let's see. Okay, so let me check. So if it has moving direction, it has t value and so on, that should be fine. I have 20 points. I also have 20 points right here. Am I getting the reference? Yep, I do. Getting from the right. Yep. Okay. And so I'm getting the let me first check if the parameter is retrieved correctly. So yeah, the parameter has been retrieved correctly. Now let me also check this NT value. Wait a minute. The conditions that I thought I wrote is gone somehow. So this has to be NTY. If the NTY goes more than parameter, then reset it. If it's NTY goes less than 0, then reset it. Okay, so I was somehow the code was deleted. I don't know why. Okay, so this should be fine. Okay, let's check. Okay, so it's moving one direction. That's good. Now let's look at where I have commented out in order to switch from one branch to another branch. Okay, now seems like it's moving. So let's also check with making a circle move, a sphere moving on top of the line so that we can clearly see what's happening here. Copy this point, copy the sphere to these moving points and merge it with the line. Let's see. And there you go. I think it's moving random. Let's increase the frame. Yeah, I think it's moving just fine. Just picking up the random branch when it reaches to the branch point. Moving randomly on top of this network. Yeah, this is what I wanted to do. If you don't want to use the randomness, then you can instead choose which primitive to go for by setting some conditions right here inside the solver. But for this testing, for this experiment, I'm just gonna deal with the randomness. Alright. Now I can make this a bit more faster if I change this speed value maybe to 0.03. It'll be more faster. Right. I can also make some trail for each point to make it look like a train running. Like that. Alright. Interesting. Okay, now let me... So this is what I really wanted to show you for today in terms of the logic, and the things that I'm going to do next is to just try to make these lines and points visualized just a little bit prettier, but just a little bit so that you can render it. Now since I have made it as a metro network, maybe it might be a good idea to set some object like station or building, something like that. And let's try to do that as well as a option. Okay, first of all, I'm going to try to create some voxelized building shape surrounding these network, maybe randomly again. And based on these, based on this original shape, I could probably create some, I don't know, box shape or something, where the close to the station. So let's see, let's get the branching point, see where I can use where can I get the branching point before doing the resample. Maybe somewhere around facet, maybe before somewhere around facet. And what I just need to do is to get the first and last point from each polyline. Now how do I do that? I think there is a node to do that. I forgot what was it. I forgot what. So just to make it simple, just gonna use the primitive wrangle just to get the first and last points. That might be too much, isn't it? Wow, I cannot think of anything else, so I'm just gonna do like this. So first get the list of points, then remove the first and last points. Seems like the order of this prim points and prim vertices were same somehow, so I'm just gonna use this prim points after all. So loop through all the points. Then if I is not equal to 0, nor I is not equal to the last point, then remove the point. Oops. I guess this has to be AND. All right. And did it work? I guess. Now I don't really need a primitive anymore, so remove prim num 0. Okay, and I am left out with only the branching point. Now I can also use the fuse to remove the duplicated one. Alright. Now let's copy some box to this point position. Maybe with the random size, but let's just go with this small constant size for now. And let's consider this as a, I don't know, station box or something. A little bit bigger. Maybe randomize the scale after all. I'm gonna change the V scale with some randomness. Okay. Maybe that's too much. Too much boxes. I don't know. Okay. Maybe there's too much boxes. Let's say I around somewhere around here. Now, I'm going to convert it into a voxel so that I can create like a modular unit for each points. To do that, I'm going to convert this into an nice offset first as a volume. Then just like I used previously, I'm going to get the points out of this volume using points from volume with some specific separation value. Maybe make this dense grid. Okay, a bit sparse. Well, we can control this later. Let's move this aside and then create a box with size equal to this point separation. Copy. This box to these points. Just like that. Now what I want to do is to remove those boxes where it intersect with these network. Okay, we don't want to have those building like penetrating these network. So I mean network penetrating these boxes. So in order to do that, I am going to remove those points which is too close to the network line by calculating the distance to these lines. I'm going to create a threshold parameter and calculate the distance using XYZ dist for second primitive, second input from the current point position. And if the distance is smaller than the threshold, then that's the point you want to remove. Like that. Right? So you can have a space for the network line. Now you can use this to create the boxes. And let's try to combine these two. See if you can have both the building and the network assigned to each other. And it's a bit hard to see what's going on here. So let's first of all color these boxes, maybe based on the y direction gradation, and then also make some alpha channel applied to make it a bit more translucent. So I can do that to these points. Maybe I can have another point wrangle to control the color and the alpha channel. So in order to control the point color based on the y values, first of all I can get the bounding box information using get b box. Then create the color-based color attribute based on the fit function based on the y value of the point position from min y to max y, going to 0 to 1. I'm also going to change the alpha channel, maybe using some parameter. Okay, now currently the color attribute is not being used, so let's use this with color node for ramp from attribute, looking at the color attribute, then going from black to blue, maybe some darker blue, and I think it's not really changing. That is because I am missing the color attribute. Alright, so I have now the gradation, point, color, as well as some alpha channel applied. Now the box looks like these. I think it's a bit more easier to see together with these line network. Alright. Now the line network itself could be drawn with a bit more thickness. If it's just a line, it's a bit hard to see, I guess. And let's also combine with a sphere that it's moving. Maybe I can color these as well. Maybe just use the constant red color value, combine with these. All right. So the network is the block itself, the building itself is not really blocking the network. It's being trimmed out. And okay, maybe I can also try to make this network a little bit of thickness. So for this one, I can either use something like polywire or wireframe. Maybe wireframe will create a bit more cleaner result. And maybe before doing the resample, let's make this smaller, like these. Now I cannot really see through these, so maybe I can also set some alpha channel to this one as well. Right, and let's see, everything has been merged. Now looks a bit too noisy. I can then make this shaded view. Maybe a little bit of more. Okay, well, really, after this, I mean, it really depends on your needs. I'm not really good at making things prettier, as you can see. But the things that I wanted to show you is these logics, so hopefully you find something new here. Now I am going to organize all those parameters that I have set into one place, and I'm gonna finish this things that I created. Let me know if you have any questions so far. If I can answer, I would like to answer it. Okay, so let me try to have all those parameters set right here. Okay, so what kind of parameters did I created? So these one, first of all. So the radius, searching radius. Search radius for the line network to be created. Number of lines. Or let's say branch number. And seed. Okay, this seed can be used in many other places, I guess. Apply. Okay, so Taxicab, so here you go. I am going to copy this. I'm just gonna reuse the same seed value for everything. It's not really necessary, but just for ease. Okay, so this is the ratio for, what was it? The diagonal curve. So Okay, what else? Resample. Maybe this can be parameterized, but I'm just gonna skip it. This one doesn't have any parameters. Nope. Moved in direction. This one also doesn't have any. If you go to the solver, we have speed. This is obviously the one we need to have. Speed and the seed, we can just bring up the one that I have copied. Alright, that's it for the solver. And maybe the radius of this sphere. So alright. What else? What else? This wire can be related to the sphere radius as well. So I can just copy this one to this wire. Maybe just add a little bit of offset. Just a little bit. No, that was too much. Okay. And what else? Boxes. Yeah, these one can also be parameterized, I guess. So the box size, or maybe station size. What's this one? This is the randomness. Scale can come here as well. Oops. I can copy the seed again. Paste the seed right here. And what else? These voxel resolutions can be parameterized as well, I think. Actually, we have another voxel resolutions, which is this one. This can also be parameterized somewhere around here. Grid snap distance. And the second one is for the building voxel. So right, getting close to having all those parameters. And alpha channel. I'm just gonna leave this. Okay, that's about it. And okay, this should do. This should have all the informations. Now, it's a bit hard to see here, kind of. Maybe I come after. I'm just gonna okay, maybe I don't really like the wire frames because it has these spheres showing up right this. Instead, I'm going to convert this into VDV. Convert back to a polygon. Maybe a little bit of adaptivity. That looks a bit better. Right. And maybe raise up some alpha channel. Okay. Like this. Okay, now since I have parameterized everything that I could, let's try to change those parameters, see what happens. If I change the number of stops, oh, in this case, I guess I should name this station. Should I? Now, more number of stations you have, or more lines you get. And it's a bit hard to see. I'm just gonna show up the lines instead. It should be easier to see for testing. Like that. Yeah, this is better. Okay, and still moving. All right. And we could change all those additional parameters like speed, making it slower, changing the seed to change all those shapes. And what else? Sphere radius, it's not really important. Search radius. So if we have small search radius, it's a bit hard to create network. If you have higher search radius, you have tons of options to search for. And you can also increase the branch number to have more branches for each point. But maybe reducing to 3 or 4 is just fine. And if you want to if you don't want any diagonal curve, then you can set this diagonal ratio to 0, which should still work. I'm gonna have to reset the simulations, and still works moving on top of this straight polyline curve, which might be still interesting, but I would rather have a diagonal curve. So I'm gonna raise up this diagonal ratio, speed up a little bit, and I guess that's pretty much it. And if you change this grid snap ratio, you'll be able to have more cleaner network. If you have smaller value, you have more organic shape network, which looks still fine. You have this kind of island somehow. Maybe you want to change the seed in this case. Yeah, looks nice. Another one. Maybe I can increase the search radius a little bit. Okay, that's fine. Looks good. Now everything is based from the pig head. Now, not much. Doesn't really look like a pig head right now. But if you increase the number of, I don't know, number of stations as well as the decreasing the grid snap distance, you start to see those pig head more and more. Maybe you have 1,000, just like that. And this should still work. I forgot to parameterize another. Oh, wait a minute. This is not moving that well. I guess the reason why this is not moving well is because of the resampling is not enough. Right here. I guess instead of making this maximum segment length, I can instead use this max segment number. And reset the simulations. Nope, not really. I'm pretty sure this is where it is creating the errors. So if I increase the... Okay, now a little bit. Maybe the speed is too fast. I'm not sure what to go for. Well, it's a bit hard to debug with this. Let me decrease the number a little bit. See if it's still gonna work or not. Huh. Okay, starting to have some weird stuff. Okay, going back to the resample node. Okay, I think it's because of this trail thing. If I change this to, just disable this trail. Now the point is moving really fast, and I guess that is because I'm making the speed too fast. I should set the maximum speed to 0.1 and then reduce the speed to something like this. Okay, so that was the reason. So it wasn't because of the trail after all. That was just a speed problem. Okay, so let me make this back to 1,000 lines or 1,000 station. Okay, still works. Great. But it's a bit hard to see what's going on here. More of a sci-fi like movement, like a sci-fi elevator or something. It's better. So I mean, things can be, I mean, I title it as a metro network, but could be, I guess that could be used for something other than like a train network. If you could think, maybe you could think of yourself using the same, a similar system. Okay, well, that's pretty much it. One last thing, maybe I should also be able to control the number of particles to run. So this is the final parameter. Okay, so let me know if you have any questions. If not, I am going to end this at this point. Okay. And I'm not sure if anybody is still watching this one, hopefully. Okay, this is it. Okay, so thank you very much for watching. Took a lot of time to finish this, but I myself enjoyed it, creating it. The algorithm itself is pretty simple, but the result that I get in terms of this network shape is, I really like it myself. Yeah, more of a metro-like network, or maybe sci-fi like curves. Okay, so thank you very much. I am, as always, I'm going to upload this file that I've created right here, the same file that I'm showing right now, to the GitHub, and so that anybody can be able to download this later after this live finishes from the video description page or from the Patreon. Okay. And also doing the Patreon page, so if anybody is kind enough to support me, that would also be great. I'll be appreciated. Okay, so that's it. Thank you very much for watching, and hopefully I'll see you next week. Recently I'm changing the date to do the live stream from Wednesday to Saturday because it's a bit more convenient for me to do the stream. Okay, so that's it. Thank you and good night.